Welcome to my fundamental. Today we are going to evaluate this integral, the integral of e to the power of negative x squared sin x going from 0 to infinity. So we have already done a video about the integral of e to the power of negative x squared and then times cosine going from 0 to infinity. You know that result, right? But I have shown a video. I have already done that integral on my previous video, so we can check it. So, but this time is sin x. Last time I done that integral by using the Feynman technique method, but this time I'm going to use the real part method. You know, sin x is equal to Im, right? Because the Arrow's formula e to the power of Ix is equal to cosine x plus I sin x. So compared to each other, you know the real part of our cosine x is just equal to e to the power. It should be real part of. It should be real part of e to the power of Ix. It's just cosine x. The imaginary part of sin x is just e to the power of x. It's just sin x. So we actually have a property which the integral of Im, you can put it outside the integral, which is Im of this e to the power of x squared, and then this one is just e to the power of x squared. Put it outside the integral. So I'm going to erase this a little bit. Just erase this. And then because e to the power of something times e to the power of something, we can add the power of it, which is e to the power of negative x squared plus ix x squared. So here's the deal. We are going to use the computing square method, which is e to the power of negative. Cut out the negative because we don't want a negative sign in front of the x squared, so we can remove the square. And the negative time, then it should have negative ix to get the positive here. And then to do this, you can ignore the negative because negative 1 squared, that you're still going to get a positive number. So I'm going to add this I. What type of this is just I over 2 in the square root. But don't forget to minus this as well. This. So when you get Im of e to the power of negative, and this one is just x minus I over 2 square, and this one I square is just negative 1. In front we have a negative, and then you get positive 1 over 4 this. So here's the deal. We can what this as e to the power of negative this time e to the power of 1 over 4. You can bring it outside the integral because it's a constant, you know, e to the power of 1 over 4. We can write this as 1 over 4 of e times I. We can put this constant outside Im because it doesn't really matter this constant the Im. So you get the integral of e power of negative x minus I over 2 squared dx, going from 0 to infinity. So we are going to use some substitution because we want to use the integral. We want to see e to the power of negative something squared. So let u is equal to x minus I over 2. Du will be equal to this, right? So you get 1 over 4 of e times Im of, be sure, plus 0 into this, you get negative I over 2. And then plug infinity inside, you get infinity, and then e to the power of negative u squared du. But how can we deal with this though? So how do we deal with this integral? So this is not 0 to infinity. If this integral is e to the power of negative e to the power of negative u squared going from 0 to infinity, you know that result is going to be the half of the Gaussian integral, which is square root of pi over 2. But this is negative, the limit is negative I over 2. Here's the deal. I'm going to use some special function here, which is, you know, the integral of e to the power of negative x squared is use some special functions, you know, that is going to be square root of pi over 2 times e out f x, e out f of x plus c. So we're going to replace this. So I am of a square root of pi over 2 times our e out f u. If I were heading from negative I over 2 to infinity. So, because square root of pi over 2, it doesn't really matter of the inside I am, so we can put it outside. You can square root of pi over 2 times 4 root of e. Be sure you need to write the 4 root of e clearly and not to get too tough. And then you already put the square root of pi over 2 outside you, and then e out f of infinity, which is 1. And then you're going to subtract that, and then e out f minus to some extent minus e out f of negative I over 2. So you'll get that, right? Here's the deal. Because e out f is an R function, you can put the negative sign outside and get square root of I times 2 times 4 from e, 4 from e, and then I am of 1 plus e out f of I times 1 over 2. Let me write this. I times 1 over 2, because we are going to use the property. So e out f of ix, this is equal to I times e out f I of x. So e out f is the that's called the error function, and then e out f I, which is just called the imaginary error function. So we can write this as square root of I times 4 root of e over 2, and then I am of 1 plus I times e out f I of 1 over 2. So here's the deal. E out f I of 1 over 2, you are going to get a real number. So we are going to take the imaginary part of inside. So the imaginary part of this is obviously which is equal to e out f I 1 half. Yes. And here's the result of this. You may also compare if this is a real part, if this is the integral of e to the power of negative x squared times cosine squared from 0 to infinity, you are going to take the real part of this, which is just 1. So for 1 time that, you get that. So the integral, you can also do the second integral. This integral e to the power of negative x squared times cosine squared from 0 to infinity, which is equal to square root of pi over 2 times 4 root of e